Welcome to part 3 in our lesson that presents an overview of Android. This part of the lesson focuses on Android's application framework and apps layers. There's several learning objectives in this part of the lesson. After completing this lesson, you'll have a better understanding about what an application framework is, and you'll also know why frameworks are useful. You recognize common system services in the Android application framework layer, as well as recognize common apps that are available on an Android device. Let's start with an overview of application frameworks. A framework is an integrated set of components that provide a reusable architecture for a family of related apps. Take a look at this link at the bottom of the slide for more information on articles I've written on frameworks in the past. Frameworks internally use an event-driven programming model that makes it easier to plug application code into the reusable portions of the framework. They're important because they help to enhance systematic reuse by providing canonical structure and functionality to apps, so the apps don't have to rewrite that functionality and structure from scratch. Typically, an app registers callbacks for specific types of events that can occur within a framework. For example, in the context of Android activities, broadcast receivers, services, and so on are used to register automatically for different kinds of lifecycle events, such as when the app starts or when it's about to be paused or resumed, and so on and so forth, as we'll see later. A callback is essentially an object that's passed as a parameter to a method provided by the framework. The framework transparently monitors event sources, such as user input buffers, network connections, files, and so on, or directories, for activity of interest that the app is registered for. When something happens that's of interest to app components, the framework is responsible for calling back the object registered as part of the callback. The processing then occurs within the context of a thread that's borrowed from the framework for the duration of a callback. When the app callback is done, the control returns back to the framework, where it waits for the next event to occur. This process of having the framework be responsible for managing the bulk of the control flow in an application leads to what's often called inversion of control, which is sometimes known as the Hollywood principle, which says, "Don't call us, we'll call you back," when an event you registered for has occurred. In an event-driven program, such as Android's activities, event broadcast receivers, and services, this process repeats over and over and over again as long as the app is running. Now that we know a little bit about what an application framework is, let's talk about the Android app framework layer and its apps layer. The application framework layer in Android contains various system services that provide apps with capabilities and information they need in order to do their work. There are several things that are provided by Android's application framework layer. One thing it does is it exposes the hardware and Linux operating system kernel up to apps, but does it in a way that's Java-centric and object-oriented rather than being programmed in C and C++, which have more accidental complexities. These system services run continuously throughout the system's operation, doing things like managing calls, managing window interactions with the user, managing access to various resources, keeping track of where the phone is located, providing notifications to the notification status area, managing the life cycles of activities, broadcast receivers, and services, and so on. And due to the inversion of control that's inherent in an application framework, these system services manage the control flow via various event handling operations and callbacks, either to system code or to application code itself. One of the key system services that's part of the application framework layer that we'll focus on throughout the course is called the Activity Manager service. And you'll get a chance to learn a lot more about what this important service does when we talk about intents, activities, and broadcast receivers. On top of all these different layers of middleware and operating system services are, of course, the apps that we use every day. And this includes things like the browser, calendar, camera, photo album app, calculator, clock, alarm, email, you name it, all the things you come to know and love are available at the top of the stack. In fact, you can look at the source code for many of the open source apps that ship with Android at this link. Naturally, there are also many other apps that ship without source code that you can download from the Play Store at the Google website. The bulk of these apps are written in Java, although it is possible to write apps, or more likely portions of apps, in other languages, typically C and C++, using the Android Native Development Kit, or NDK. This is not a common use case, however, and it's actually actively discouraged by the Android documentation, so we won't cover the NDK in this course. This concludes part 3 of our overview of Android, which focuses on application frameworks and apps in the Android software stack.